Hello everyone. In this lecture, we will discuss artificial variable techniques and the method is big M method. So let's start. Here problem is maximize z minus 2x1 minus x2 and these are the constraints. So first we write the standard form of LPP. It is already given in the maximization form, so no need to convert it. So you can write maximize z minus 2x1 minus x2. And the constraint, look at this, here there is equal sign, so first write this as it is, plus x2 this equal to 3. Second one is greater than equal to sign, here we will use surplus variable, so 4x1 plus 3x2 minus s1 this equal to 6. And second one, this is less than equal to sign, so we will use slack variable. This is surplus variable, here we will use slack variable x1 plus 2x2 plus s2 is equal to 4. S1 and s2 are slack and this is surplus variable, this one is slack variable. Now look at this. Can we find initial basic feasible solution from this one? Number of equations 3, number of variables 1, 2, 3 and 4. So extra variable is 1. So if you assume suppose x1 equal to 0, x1 equal to 0, then you will get the remaining variables, you will get the value of x2, s1 and s2. But look at this, if you write the matrix corresponding to x2, s1 and s2, will not get a unit matrix, because here look at this coefficient is 3, 2 is a minus 1, so it will not be a unit matrix. It means this cannot be considered as initial basic feasible solution. It means, where is the problem? Here the coefficient of S2 is 1 and S2 is absent from first and second. It means this will form 0, 0, 1. So this is perfect. But here we need to add artificial variables. So in the first and second we will add artificial variable. So you can write on adding artificial variables. Artificial variables A1 and A1 and A2. So A1 and A2, the equation will be 3x1 plus x2 plus A1 equal to 3, 4x1 plus 3x2 minus s1 this equal to 6 plus A2 x1 plus 2x2 plus s2 this equal to 4. So only two artificial variables are required. Now look at this. Number of equations 3, number of variables 1, 2, 3, 4, 5, 6. So it means 3 variables are extra variables. So you can initially you can assume x1 equal to 0, x2 equal to 0 and s1 equal to 0, so that we will get the values of a1, a2 and s2, because corresponding to these variables a1, a2 and s2 we will get a unit matrix. A1 is there but not present in these two equations. It means it will form 1, 0, 0, a2 will form 0, 1, 0 and s2 will form 0, 0, 1. So we will get a1 equal to 3, a2 equal to 6 and s2 equal to 4. So these are basic variables and these are non-basic variables. So now this is the initial work which we have to do. Now come to the big M method. For big M method, what we have to do? We have to change the objective function by adding these artificial variables a1 and a2 in this objective function. This is minus 2x1 minus x2 and the coefficient of these. If it is a problem of maximize, then we have to write in this form minus m a1 minus m a2. If it is objective function is maximization, the sign will be negative, and if it is a problem of minimization, then it is positive. What is m? M is a very large number, and you can say it is a penalty of using these artificial variables. And if it is a problem maximization, penalty is negative. So a higher penalty will be there. So m is a very large value. You have to assume that, suppose in practical science you say, suppose for example all these values are 2, 3, 4. So you can assume m is 1000. So m is very large value, and this large penalty is added. So negative sign is there if the problem is of maximization. So in this way we can change this objective function utilizing these two additional uh, values here, minus m a1 and minus m a2, and you will see these are the penalties of adding artificial variable. Now taking this objective function and these constraint, you will solve in the simple way as you do the simplex method. So create the first simplex table. Now the basic variables are a1, a2 and s2. So here we write a1, a2 and s2. The coefficients are here. For a1 this is minus m, for a2 this is minus m, for s2 is not there, so its coefficient is 0. The value of xev, this is 3, 6 and 4, and these are the coefficients. Here you can write 3, 4, 1, so this is 3, 4, 1. Now x2 1, 3, 2, so this is 1, 3, 2. Now s1 is not there, so s1 is, you can write it 1, 0, 0. s1 x1, look at s1, so s1, oh no, s1 is not there, this s1 is 0, s1 is here, so you can write minus 1, and this is 0. Now s2, look at this, s2 is only there in the third equation, so you can write 0, 0, 1. a1 is there, we have to see these equations in place of this. Consider these equations, okay, not this one. So this is a1 0, 0, s2 0, 0, 1, a1 1, 0, 0, a1 this is 1, 0, 0, and a2, look at this, a2 is there in the second equation, so this is 0, 1, 0. So now look at this, a1, a2 and s2, you can write s2 here also, but no need to change it, because simply we can assume this will form a unit matrix if we change the order. So this a1 is 1, 0, 0, a2 0, 1, 0, s2 0, 0, 1. Now calculate value of z. Then look at this, minus 3m minus 6m, this is 0, so minus 3 minus 6, this equal to minus 9m, so this is minus 9m. Now look at this, minus 3m minus 4m minus 7m, okay, this is 0, and here we have to find this, we have to write all this coefficients here also. So coefficient of x1 is minus 2, this is minus 1, 0, 0, minus m and minus m. So if you calculate this, minus 3m minus 4m minus 7m minus 2, so you can write it, minus minus is plus, this you can write to 2 minus 7m, because minus minus this will become plus 2, minus 3m minus 4m minus 7m, minus minus 2 means plus 2, so 2 minus 7m. Similarly, if you calculate this, minus m and minus 3m minus 4m, and this is plus 1, so 1 minus 4m. Similarly, calculate this, will be 0 and m, this is m, this is 0, 0, so this is 0 is minus m, again subtract it with minus m, so this becomes 0, and again this is 0. So these are the values of, this is the value of delta 1, delta 2, this is the value of z, this is delta 1, delta 2 and delta 3 and so on. Now look at this, m is a large number, very large number. It means this is a negative quantity, this is again a negative quantity. It means some negative values are there, so this solution is not an optimum solution. So you have to choose the most negative, and the most negative is this one because the coefficient of m is 7 here. In this case it is 4. So most negative is this one. So this variable is the incoming variable. Now we have to find the outgoing. For outgoing you can find the ratio of xb and x1. So 3 divided by 3, this ratio is 1. This 6 divided by 4, you can write 6 divided by 4. This is 4 divided by 1, this is 4. Obviously the lowest one is this one, so a1 is the outgoing and this is the pivot element. So here go to the next slide. I have written all these values here. This a1 is outgoing, this is incoming, this one is the pivot. So again simply apply the rules. Say this one R1, this is R2, this is R3. So how can I write the rules for the next table? So R1, this is 3. So for R1 you can write R1 replaced by R1 divided by 3. So this will become 1. Now for R2, what you have to do? R2. This is 4, you have to make it 4. So first divided by 3 and multiplied by 4. So this will become R2, 4 by 3, 4 by 3 R1. Similarly, rule for R3, this is 1. So R3 minus, how can we make it 1? Divided by 3. So R1 by 3. So apply all these rules I have written. You can find all these values here. This one is, look at this now, in place of a1 you will write x1, a2 already there, s2 already. So coefficient of a2 is, this is minus m, this is 0, and this x1, coefficient of x1 is minus 2. Okay, and all these values, we will calculate all these values here with the help of these rules. So I have calculated all these values here, so you can check and verify all these results here in this table. Similarly, here if you look at this, I have calculated the value of z, this is delta 1, delta 2 and so on. Now again look at this here. This is the most negative value. Negative value is there, it means this is again not an optimal solution and this is the most negative value. Then we will calculate the ratios. Here I have calculated all these things. Ratio is xb by this one x2, so this ratio is first is 3, this is 6 by 5, this is 9 by 5, so this one is minimum, so this is the outgoing. This is the key element. So you can frame the rules, you can write, say this is R1, R2, R3, so you can write rules R2, this is 3 by 5 R2, and now look at this for R1, how can we write rule? R1, this is 5 by 3, is 1 by 3. It means you need to divide this by 5, then it will become 1 by 3. So R1 minus R2 by 5 only. So if you divide it by 5, then it will become 1 by 3. Now for R3, this will R3. Look at this 5 by 3. This same as this one. So you can simply write R3 minus R2. And I have calculated all these values here. So if you can check and verify all these values here. So if you see here, z is minus 12 by 5, delta 1 0, 0, 1 by 5, m minus 2 by 5, m minus 1 by 5. M is a very large number, so all values are greater than equal to 0. So greater than equal to 0 means this solution is the optimal solution, and the variables are x1, x2, x1, x2. So s2 is the slack variable, no use. So the final answer is x1 equal to minus 2, x2 equal to minus 1, and the maximum value of z is minus 12 by 5. So in this way you can utilize big M method. So I hope that you got the concept of big M method. Thank you.